Welcome to another video. Now let's provide a solution to this problem. Okay. Now we are given 3 to the power x equals to x to the power k. So how do you solve for x? Now, before that, when you have 3 to the power x equals to x to the power 3, finding the value of x will be complicated and intricate as well. But with the help of the Lambert W function, we can find the approximate value for x. Okay, so to set the ball rolling, let's take log on both sides. So we have ln of t to the power x equals to ln of x to the power cube. So this one is a power rule, so the x will come here and the 3 also come there. That will be x ln of 3 equals to 3 ln of x. Remember, we have the x. So what we are going to do here, size by x times 3, and we have x times 3. The idea is to bring the x on the on the right, and then so this side will cancel and this side will cancel. So I've left it. So we have ln of x on x equals ln of 3 on 3. So we have that. So ln of x on x, ln of 3 on 3. Now when we have e raised to ln of box, the answer is box. When we have e raised to ln of m, the answer is m. Why are we doing this? We want to apply the Lambert W function. Now when we have W function of p times e to the power p, the answer is p. Now you can check out one of my videos that explains the natural log function. Okay, so I'll put the link under this so that it will give you the in-depth knowledge about how the Lambert W function works. Okay, all right, so let's move on. So let me support this x here. So but before that, when we have 1 over x is the same as x to the power minus 1. So before I support this, let me write this one as ln of x times x to the power minus 1 equals to ln of 3 on 3. Okay, let me support this one as I write this one as ln of x times e raised to ln of x to the power minus 1. Remember the rule, this one remains as x to the power minus 1 equals to ln of 3 on 3. Okay, but we can do something to this. So remember the power rule, ln of x e. So this side is -1, -1 ln of x. So that will be negative ln of x equals that on 3. All right. So we have ln of x e minus that equals to, let me check it from there again, ln of 3 on 3. Now before we can take the Lambert W function. We have to make sure what is here and what is there are equal, but we have negative here, and this side there is something missing here, so we have no option but to balance it by multiplying -1 on both sides. So that will be minus ln of x e raised to ln of x equals to negative ln of 3 on 3. Perfect. Now what is here and what is there are equal, so we can go ahead and take the Lambert W function. So we have W function of this ln of x e minus that equals to W function of that on 3. Remember the rule, this and that are equal, and therefore taking the W function of this will make this side be negative ln of x equals to W function of that. Okay, so remember the power rule function. Okay, so we have -1 here, so it will come here. That will make this side ln of x a power -1. So we have ln of x to the power -1 equals to, so W function of minus ln of 3 on 3. Okay, now we have x, so we can remove this ln by raising both sides. So e raised that, this side will go. I will leave with x to the power -1 equals to e raised W function of ln of 3 on 3. We still have minus there, so x to the power -1 is the same as 1 over x equals to e. So we have W function of that. Okay, so we can make this side over 1. Therefore, my final answer will be 1 over e raised to W function of that. Let me write it well. 1 on raised to minus ln of 3 on 3 on that. So when you plug this one in Wolfram alpha, the approximate value for x will come. All right, thanks for watching.